episode 232. Welcome to Data Skeptic, a podcast about data science and fake news from an algorithmic perspective. Here's your host, Kyle Polich.
Coming to you from Los Angeles, California. Welcome to the podcast that has never once given out a stock tip that wasn't a good payoff. This is Data Skeptic, and we're here at the midterms. No, not the U.S. election midterms, although that's coming up too and we'll have something to say about it. No, today is the midterm for our series on fake news. I wanted to regroup a little bit, review where we started, what we've learned, and what I have yet to cover. Let's start with the source of fake news. Or perhaps the question is, why on some occasions do people create it, and on some occasions they create algorithms that automatically generate it? We heard from one guest who was quite confident that it wasn't politically motivated, that in fact, it was profit motivated. And there's undeniably truth in this. We heard from another guest who thought that political motivations played a much more significant role. And the reality is I think it's a bit hard to measure which one of these two is more correct. Are these the only two categories? I guess the third category should be people doing it for pure mayhem, for the lulz. Not necessarily prominent, but certainly not something we can exclude outright. It does seem then that these three categories really cover the gamut of possible motivations for creating fake news. Now, everywhere online, we use algorithms to sort content. In fact, we do it so frequently, it's rather ubiquitous to people who didn't experience the days before search engines. Our social platforms, they're sorting content for us. And even if you set your configuration in those systems to always show you things in chronologically descending order, no adjustments, no filters, no algorithmic improvements, they are still algorithmically sorted, albeit by a rather simple algorithm. So naturally, the social media platforms and other websites, they have this goal. They want to improve their platform to get their users to like it more, or to spend more money, or to just generally be more engaged with that platform. There's no way to derive from first principles how to do that. Human beings are unpredictable, stochastic, dynamical systems. So what do? You run some experiments. It comes as no surprise that many of these large companies have built their own A/B testing platforms. Is there no room for one standardized, federated solution? I mean, those things exist, sure, but this is a wheel many people reinvent. Why? Because they want something highly specialized to their highly specialized needs. A/B testing can begin with simple discoveries, like always include an image, from which sites learn that people tremendously respond to that. Gave us a 5% lift on whatever metric we're interested in. Well, the days of 5% lifts are gone. Many of the data scientists involved in these sorts of efforts are pursuing improvements in maybe the 4th or 5th decimal place sometimes. Areas where the statistics become tricky in a way we're going to cover in a future mini-episode. Now, people who do A/B tests, they're making one critical assumption, and it's always important that they realize it's an assumption. They assume that whatever they change, let's say changing a button from blue to green, impacts a finite and known list of observable metrics. So let's break that down. Change the checkout button from blue to green. Either one will get more clicks in a way that is statistically significant, or there will be no measurable difference between these two outcomes. And that measurable difference assumes you know all the metrics. In this case, did they click the button? This doesn't account for some small contingent of the public who is deeply offended by the color green and, having encountered it, will never shop at your store again after just this one last purchase. While ridiculous, let's run with it. People who saw green make the final purchase and get offended and never come back to the site again. We should be tracking metrics of repeat rates. Maybe not in this case because it seems implausible, but in addition to click-through rate on the checkout button, we ought to be checking for repeat purchase in N number of days or some sort of survival analysis type modeling like that. I find myself frequently referencing our episode on Goodhart's Law. It states that once a measure is turned into a target, it ceases to be a good measure. When an e-commerce store gets people to buy more goods, that's a target only for the e-commerce store. When a social media platform provides the mechanism for users to find content and ranks it algorithmically, producers of content now have an incentive to manipulate the algorithm. Surely the click-through rate is important, so set up a botnet and start clicking on your own content. Now eventually, some clever team of data scientists inside the company should start looking into that problem. Actually, you know what? It should start with the software engineers, because frankly, most of the tricks people play are simple stuff. You know, if they're using the same IP, same cookie, session data, tracking stuff like that, let them do it, but quietly filter them out of the data. Or better yet, mark them as invalid and put them through the standard data pipeline. That way, when some data scientist at the other end wants to filter them out, that's easy. Or if they want to analyze trends in that area, they can still do it. Don't destroy the data. Just label it. Storage is cheap. So I've taken you listeners on a little history lesson through the decades as we've gotten into our topics of fake news. We started with spam filtering and discussed how the naive Bayes algorithm was an early winner in that space. Why was it easy to solve the spam problem? The spam problem did persist for a long time, but was eventually algorithmically solved. What enabled that to happen? Why could machine learning solve that problem? Well, for the same general reason machine learning can solve any problem. It's because there's some signal or pattern in the input data that allows for a clean separation of the classes you're interested in. Spam and not spam, legitimate click and fraudulent click, real or fake news. Now, as mentioned, I'm quite confident spam filtering today is much more sophisticated than just some simple naive Bayes. Certainly a great number of features come out of the metadata, network analysis, this sort of thing. But again, the data admits that signal. And don't forget the user's own behavior. People who mark emails as spam, people who don't open them or open them and delete them quickly, open them and unsubscribe, open them and mark them as spam then. The data easily admits the signals. You just have to use them. Somewhere along the way, these content providers decided they needed to monetize through advertising. Much to my disappointment, people typically use the word organic to describe the sort of natural results. Organic is not the same thing as natural, and search results contain no carbon, so not a great word choice, but we're stuck with it. Organic are like those algorithmic results that the core Google algorithm serves up, or maybe your Facebook feed serves up, or Twitter serves up, even in a world where there are no advertisers. So why advertise at all? Well, you want to get your message out to a wider audience than you have access to. And for many people, that's implicitly undesirable for some reason. I get it. I don't want to be bombarded with nonsense that has nothing to do with me. But from my point of view, if someone can serve me novel, timely things that I want, with minimal annoyance, that's a service. But I digress. Listeners, if I asked you what were some of the most complicated machines on the earth, I hope one of the things that would pop into your mind would be the human brain. And by understanding how it works, we can actually improve how we learn. And that's why I want to recommend the Great Courses Plus to you and their fascinating course called The Learning Brain. The Learning Brain approaches topics like amnesia, consciousness, memory, and really explores the psychological sides we don't get to here on Data Skeptic. And even though the human brain might be one of the most complicated machines, it's still biological, of course, affected by stress, emotion, sleep, aging. And Professor Thad A. Polk from the University of Michigan takes you through 24 lectures on these and other topics related to your learning brain. This is a perfect course for Data Skeptic listeners to get started, or choose from any of their thousands of other lectures available. With the Great Courses Plus, your subscription will get you unlimited access to stream their entire library. If you check out The Learning Brain and it's not for you, that's all right. There's courses on robotics, mathematics, economics, history, just about any subject you might decide to take an interest in. You can enjoy these lectures anytime, anywhere with the Great Courses Plus app. And the app's great. It actually syncs stuff to your device. So if you're going on a plane or someplace where you're not going to necessarily have confident Wi-Fi, stock up on some lectures. So we have a special offer for Data Skeptic listeners. I know you're going to love the Great Courses Plus just as much as we do. Get started with a free trial to explore if the Great Courses Plus suits your learning style. You're going to need to go to a special URL to get that offer. All right, pay attention now. It's thegreatcoursesplus.com/data. One more time, it's thegreatcoursesplus.com/data. So search engines quickly learned, or at least the ones that remain successful quickly learned, that users don't like to be fooled. They don't like to click on ads that misrepresent themselves. They don't want to be taken to spammy sites or questionably valid sites, or worse yet, sites that are doing something illegal, stealing credit card numbers, who knows what. Oh, or installing malware. That used to be a big problem back in the day. Seriously, all you'd have to do is visit a site, and the JavaScript would have some backdoor it found a way into your system. It were terrible times. We rarely see those sorts of zero-day exploits anymore. So the past couple mini episodes, and guys, I know they're running long. They're no longer minis, all right? They're just episodes. That's how we're doing it now. We've been talking about digital ads, and really specifically, most of my commentary is colored by my perspective doing search engine marketing, SEM ads, the kind of things you would buy on Google's AdWords product. Or I don't know if Overture's even still around. That was another big product. Display ads are a beast all their own with demand-side platforms and supply-side platforms. Facebook has its quirks, and if I ever get to know them, I'm sure Instagram has its own quirks as well, as does Twitter. Quirks meaning the mechanism, the way by which they enable people to purchase ads. Because as much as we might, some of us, hate ads, compare what we have today to the days when television was the main source of media. It was impossible to target. The best you could do was sort of like time-of-day targeting. Assume it was kids and unemployed people, maybe retired people during the day, that sort of thing. Or newspapers where one size fits all. Every print is essentially the same. Every user sees the same ads, no targeting. So it seems to be win-win when these platforms do some targeting. We can argue about what level of targeting is appropriate, but it can do no worse than it did before. Yet, as I mentioned, by its very nature, an advertiser is trying to push their message harder than it might organically grow. This is either because they haven't picked up the momentum they might otherwise have if people had common knowledge of their products and services, or it's because they're trying to push those services out excessively broadly, going on a fishing expedition, annoying 100 people in an effort to rein in 3 new customers. And that would be a success. 3% conversion rate for many industries is outstanding. We talked about how things like click-through rate and quality score, and I'm sure many other features, enable these advertising platforms to provide mechanisms which penalize bad behavior and discount good behavior. By good and bad behavior, I mean when advertisers take the time to appropriately target their messages, doing so using the tools of the platforms. But that doesn't always happen. Of course, what those platforms can learn about us is useful for targeting as well. Many people don't like this, and while I admit certainly there is some line that can be crossed, I don't think that line is at total anonymity. I don't mind people knowing I'm a male in my 30s, living in Los Angeles. If that helps you annoy me less by slightly targeting better, let's do it. And there's an implicit information exchange here. I'm giving something up and getting something back. So spam ads got solved by a combination of these mechanisms, and through feature engineering by gathering data of the content of the page. Now we should observe something novel about machine learning here. What we want to know is, if a user clicks on a certain ad, are they going to be disappointed or feel tricked or feel unsafe when they arrive at the ad's destination URL? That's the label we'd like to predict in our data set. Okay, so what information does the user use to make up their mind? Well, whatever it is, it's on the page. The page tells the whole story. An HTTP request contains the full data set. Yes, I agree we're not going to build our features on HTML tags. Nor do I necessarily think we have to go to the other extreme where we render that as an image of a page and we train a convolutional neural network. Although that is a very viable approach. But certainly somewhere in between, the right level of abstraction exists. The right level of feature engineering was done. And that problem was solved, for the most part. So why don't the same tools that we use to filter out spam and false advertising and things like that, why can't we just directly use those to detect fake news? Well, sometimes you can. In an earlier episode, we heard from Kai Shu and Mike Tamir, who built independent projects attempting to use machine learning to classify fake news. Very novel stuff. Did you guys check out their tools? Go back to the show notes for that episode. Look into it. But I think we already know their tools don't totally solve the problem. They're helpful, they're directionally correct, but they're incomplete. And what makes them that way? Ultimately, I claim, is that they don't have the full signals they need in the data set. Yes, there are many fake news sites where, at a glance, they're obviously fake news. Things that look like peculiar impersonations of news websites. Sites that look auto-generated. You know, a lot of these are hosted in very specific ways on certain CDNs or set up to redirect in a certain way. Those are features that can be detected. And the low-hanging fruit of fake news can be easily filtered, often just by labeling the whole domain name. But in the middle are the interesting cases, those that might fool a person. We heard a little bit from Gordon Pennycook about people's abilities to detect fake news, and interestingly, how they were better at detecting fake news that matched their political alignment. Counterintuitive at first, but in retrospect seems quite plausible to me in the fact that probably you know the players and the issues a little bit better and you can detect what's askew from norm. And therein lies the key difference. You know the players, you know the stories, you bring context to the table. Machine learning doesn't do this very well yet today. We take for granted that however old you are, you have that many years of training data. You've got a knowledge base in your mind. You can retrieve people, places, and other entities, associate facts with them, and do logical inferencing all on the fly. All of these things are possible in a machine, just not exactly implemented today. I'm confident in my lifetime there'll come a day when we can tap into available data streams like that, where I could take some sort of knowledge representation component of Wikipedia and on the fly pull out what I need for some machine learning solution. You can kind of sort of do that one today, actually. They've got some sort of knowledge graph thing I haven't played around with too much. But what is preventing machine learning from just completely solving this fake news problem? Well, for starters, it's a lack of a signal. User behavior isn't quite as good of a clue as it was for spam. People are sharing fake news, oftentimes more quickly and more frequently than real news. Human beings are not providing useful signal. Now, one novel thing, and we're going to get into this in some future episodes, are these fact-checking sites. Now, for the moment, set aside some of the questions about who watches the watchers and that sort of thing, but if they could rate every page on the internet, that'd be a tremendously useful signal. But surely there's not enough computational power to do that, because there has to be a manual step. Establishment of truth, or accuracy of the facts, that's a hard language problem. That is arguably in the same ballpark as the Turing test. So give these social platforms a little bit of a break. I've heard every indication that they're working on a lot of the right algorithmic steps, but these are not problems that are going to get solved overnight. Fake news will play a role in the upcoming United States midterm elections. In exactly what capacity, we don't yet know, and to what effect, we don't yet know. It's history in the making, and we're going to be covering that from now until the end of the year. We're going to start talking more about truth and what truth is. I'll get into theorem provers. I'm not going to get to Gödel this time, guys. Some other theme, we'll get into incompleteness. I'm looking forward to it. I got to talk to some of these fact-checking sites. I want to get more guests looking into the spread of fake news and botnets and things like that, as well as legitimate empirical measurements of the impact of fake news. I don't think anybody's done a good job of that yet. Lastly, I'm looking for someone who knows something about the computer forensics side of these things. And last but not least, I wasn't sure if I was going to do this or not, but what the heck, let's go ahead and do it. I need to talk to somebody from Facebook. There's no way we can wind up this series without it. And I'm not going to talk to some marketing person that has 3 bullets to repeat. I want to talk to a legitimate data scientist type person. Some real researcher who's going to talk about some of the efforts they're going into. Now guys, I got to do my legwork. I got to call the press department over there, see if I can get in. But I'm a small fry in the grand scheme of things, and this is a hot button issue. But here's the thing. I guarantee you this show is at most 2 degrees away from Mark Zuckerberg. Somebody knows somebody who knows somebody. Now don't pester the man. And I don't want to interview him. I admire his testimony from Congress, said a lot of great things. And I have every indication to suspect that he's put his team on the right path to tackle this problem. Let him know I'm not Howard Stern, but I want to talk about the sort of scholarship side about what they're doing here. I'm going to try and make that happen for you guys. If anybody knows somebody, let me know. Oh, and maybe we need to touch on the First Amendment in here, because that plays an important role. Anyway, last but not least, we're looking for a new intern. If you're interested and live in the Los Angeles area, send a cover letter and resume to interns@dataskeptic.com. Send PDF files. Do not send anything else, please. Following directions is the first important filter. 2 attachments, resume, cover letter. Put them together if you want. This is an analytical role. You're going to do some technical stuff. You're going to deploy some code. But it is also an on-air position. So we're looking for someone who has a little bit of a background, broadcast, production, nothing too fancy, but you need to be comfortable on air. And your resume should already make that clear to me. We're also looking for someone who will align well with our upcoming theme for 2019, which of course is top secret. So apologies for people who get disqualified based on that criteria. This is a paid position, so if you're interested, send an email, and just 1 email, guys. 2 emails disqualifies you. interns@dataskeptic.com. Oh, in Grand Rapids, Michigan, I'm going to be at Big Data Ignite next week. Give me a shout out on Twitter if you're there. Maybe we can meet up. I'm there for the whole conference. I give a workshop and a talk. Maybe we can go track down Mustard Plug, I don't know. And then coming up in October, the SoCal Data Science Conference. I'll give you the dates next time, but pay attention. So long, everybody.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Support the show and find extended materials at dataskeptic.com.